All right, so what we're going to do today is we are going to shift our focus this time to the exterior angles of a polygon instead of the interior angles of a polygon. We found out yesterday that there is a pattern to the sum of the interior angles in a polygon. Perhaps there might be a pattern to the sum of the exterior angles of a polygon as well. What do you think? No? All right. Bunch of skeptics. Let's find out. Okay. So first thing, what I'm going to do is I'm going to start with the easiest case, which of course is a triangle. And what I mean by an exterior angle is an angle that's formed by one of the sides of the shape but then continues outside of it. Okay? So this is a shape with one exterior angle at each vertex, and that's what we're going to talk about today. If we have one at each vertex, what will they add up to? And so the first thing we might want to do is, I don't know, make a little conjecture. What do you think? The inside angles of a triangle add up to what? 180. So what do you think the outside ones add up to?
360.
360 we're going with? Okay. Well, there's the first one. And there's another one. And here is another one. And let's see what they all add up to. I'm cheating?
Yeah.
Okay, so it looks like your guess for triangles, at least for this triangle, is correct. Maybe I cheated and I made one specific triangle that I knew that this would work for. So let's do my favorite game, I should say, and move the point around a little bit so you can draw some different triangles. And what you should notice is that the measure of the exterior angles is changing, but what's true about the sum of them? It still adds up to 360. Okay? So do you believe that in any triangle the exterior angles add up to 360?
Yes.
No? Okay, yes. All right, let's take a look at our next shape, which would be a what? Hello. Up here. Okay. What would be the next shape that I would want to consider? Quadrilateral. I'm going to add another side. Any guesses or conjectures what the exterior angles of a quadrilateral? You're going to go 720? You're going to go 540? You're going to add 180 on there?
1080.
What? 540? Add 180? Okay, let's take a look. So now I'm going to get a quadrilateral going here. And I'm going to play the same game. I'm going to measure one of the angles at each vertex. So I got a 97 right there. Whoa. That does not seem like 51, does it? Oh, I went the wrong order.
Good job.
Thanks.
No problem.
At least I caught my mistake. There we go. Okay, that one is 90.
Friday. What?
Okay, take a look, please. What does it look like those are going to add up to? Are we going to get to 540?
360.
You're going 360 again?
Survey says.
Survey says?
Did you forget?
I did not forget an angle. You forgot to use your math.
I was thinking of it. I was trying to.
Okay, that also adds up to 360, but you should have known that already. Because what's a very easy quadrilateral? Yeah, square. A square has 4 90-degree angles inside, okay? And so how many degrees are all the angles going to be on the outside? 90. And what will those add up to? 360. And so we know for sure that will be true of a square without even doing any math. And now if we make this and send this thing in motion and get some of these points to move around a little bit, you can see the same thing that was true with the triangle, that the angles might change. Okay, hold on. What just happened? Yeah, so I don't have a quadrilateral anymore. Now I've got something. I've got 2 triangles, so I've got a mess. Okay, so that doesn't really count. But you can see again, what did those add up to? 360. Okay, so what would you guess would be true if we did a 5-sided figure? 360. And Curtis sort of did a visual thing for me that it sort of explains why. Girls, the reason that they add up to 360 is because you're going all the way around the shape in a circle, and the circle is 360. So if you get all the way around the shape, that's going to be 360 as well. Okay? So, a couple of conjectures for you. First, we're going to go for any polygon . Okay, so there's the, okay, yeah, so that's not the sum of the measures of the interior angles, that's the sum of the measures of the exterior angles, and that's only 1 at each vertex, okay? So that's 1 at each vertex. You can't cheat and use 2, all right? And what this does is this gives us a really easy way to figure out how many sides a regular shape has if we know how many degrees one of the interior angles is. So let's go back. Let's go back to the archaeologist problem, and she found a plate that had an interior angle of 160 degrees, okay? So follow along with me, a little thought process here. If you have an interior angle that is 160 degrees, what is the exterior angle right next to it going to measure?
40. 108.
No, just shout things out. Think about it. Make it a guess. 20. Yes, because when you have the corner of a shape, an exterior angle right there is going to be supplemental to that. They'll always make a straight line. So if the interior angle is 160, the exterior angle is 20. Okay? What will all of those exterior angles add up to? 360. So what's a quick way to figure out how many exterior angles there are? 360 divided by 20. And that would once again give you 18 exterior angles, which means that you have 18 sides. So you can do it that long way that we did for those couple of exercises from yesterday. But if you just recognize that the interior angles and exterior angles are supplementary, then you can very quickly find the measure of an exterior angle. And if you go 360 divided by that, then that will tell you how many sides you're dealing with. Okay?
I like it.
You like it?
I like it.
All right. Are we good?
Yeah.
So only 2 simple things there. One is that all the exterior angles of a polygon, no matter how many sides it has, will always add up to 360 degrees. And then a little hint on how you can use that to figure out how many sides a polygon has. Okay? All right.
I can't see what it is.